topic concerns supporting manufactured wiring within grid ceiling systems, specifically addressing a disagreement on code interpretation. The core of the issue lies in whether manufactured wiring, often referred to as ReLoC wiring, can be supported by the ceiling support system itself, or if it requires independent support. The electrical code states the ceiling support system is permitted to support branch circuit wiring and associated equipment where installed in accordance with the ceiling system manufacturer's instructions. The problem arises because ceiling manufacturers often don't provide specific instructions for supporting electrical wiring, considering it an electrical rather than a structural concern. The city is requiring independent support for ReLoC wiring, classifying it as branch circuit wiring that falls outside the scope of what the ceiling system can support. This stance conflicts with the permissibility stated in the electrical code, which allows the ceiling support system to support branch circuit wiring when manufacturer instructions are followed. However, the absence of specific instructions from the ceiling manufacturer creates ambiguity. A key piece of evidence is the existence of underwriters' laboratories, or UL, listed clips, like those made by CADI, designed specifically for supporting wiring in grid systems. The availability of these clips suggests that this method is a recognized and acceptable practice within the electrical industry. The absence of explicit instructions from ceiling manufacturers, like Armstrong, on electrical wiring support further complicates the matter. Armstrong's position, as reflected in the conversation, is that they provide load data for their grid systems but do not offer guidance on electrical attachments. They emphasized that any attachment to the Hanna wires must not affect the levelness or squareness of the ceiling installation, referencing American Society for Testing and Materials, or ASTM, C6.36, which states that local kinks and bends shall not be made in the Hanna wires as a means of leveling carrying channels. Here's a breakdown of the key considerations. 1. The electrical code permits the ceiling support system to support branch circuit wiring when installed according to the ceiling manufacturer's instructions. 2. Ceiling manufacturers typically don't provide specific instructions for electrical wiring support. 3. The city interprets ReLoC wiring as branch circuit wiring requiring independent support. 4. Underwriters' laboratories listed clips exist specifically for supporting wiring in grid systems. 5. The ceiling manufacturer focuses on load capacity and maintaining the integrity of the ceiling installation. To resolve this conflict, it's essential to understand several technical aspects of electrical wiring, ceiling grid systems, and relevant codes and standards. Firstly, branch circuit wiring. Branch circuits are defined as the circuit conductors between the final overcurrent device protecting the circuit and the outlet. The National Electrical Code, or NEC, covers the requirements for branch circuits in Article 210. The city's position is that ReLoC wiring constitutes branch circuit wiring. Secondly, ceiling grid systems. Suspended ceiling grid systems are designed to support the weight of ceiling panels, light fixtures, and other components. The load capacity of the grid system is a critical factor. Ceiling manufacturers provide load data for their systems, specifying the maximum weight that the grid can safely support. This data is typically expressed in pounds per square foot. Thirdly, support requirements. The NEC requires that wiring be supported by independent supports. Section 300.11 addresses securing and supporting wiring. The key question is whether the ceiling grid system itself can be considered an adequate support for wiring, especially when using listed clips designed for that purpose. Fourthly, Underwriters' Laboratories listings. Underwriters' Laboratories listing signifies that a product has been tested and meets Underwriters' Laboratories safety standards. The fact that CADI manufactures UL-listed clips for supporting wiring in grid systems indicates that these clips have been evaluated and found to be safe for their intended purpose. Fifthly, code interpretation. Code interpretation is crucial in resolving this type of conflict. The electrical inspector has the authority to interpret the code, but their interpretation should be based on sound engineering principles and the intent of the code. The NEC is intended to ensure electrical safety, and interpretation should not unnecessarily restrict methods that achieve this goal. Sixthly, ceiling manufacturers' instructions. The NEC allows the ceiling support system to support wiring when installed according to the ceiling manufacturer's instructions. However, when the manufacturer doesn't provide specific instructions, the electrical inspector must make a judgment based on other factors, such as the load capacity of the grid system and the use of listed support clips. Seventhly, load calculations. It's important to calculate the total weight of all components supported by the ceiling grid, including the ceiling panels, light fixtures, wiring, and support clips. This total weight must not exceed the load capacity of the grid system. Eighthly, relevant NEC sections. Several NEC sections are relevant to this issue, including Section 300.11, which covers securing and supporting wiring, Section 314.23, which addresses boxes and fittings, and Article 410, which covers luminaires, lamp holders, and lamps. Ninthly, communication. Effective communication between the electrical contractor, the electrical inspector, and the ceiling manufacturer is essential. The electrical contractor should provide the electrical inspector with documentation such as the underwriter's laboratory's listing for the support clips and the load data for the ceiling grid system. The electrical inspector may need to contact the ceiling manufacturer to obtain clarification on their position regarding electrical wiring support. Tenthly, documentation. All relevant information, including code sections, underwriters' laboratories listings, load data, and communication records, should be documented to support the chosen method of wiring support. Now let's consider specific technical aspects. Electrical metallic tubing, or electrical metallic tubing, also called thin-wall conduit, is an unthreaded thin-wall race-wave circular cross-section designed for the physical protection and routing of conductors and cables and for use as an equipment grounding conductor when installed utilizing appropriate fittings. Electrical metallic tubing is covered in the NEC Article 358. The trade sizes are 1/23/4, 1/11/4, 11/2, 2, 21/2, 3, 31/2, and 4. Electrical non-metallic tubing, or ENT, is a pliable, corrugated racewave circular cross-section designed for the physical protection and routing of conductors and cables and for use as an equipment grounding conductor when installed utilizing appropriate fittings. Electrical non-metallic tubing is covered in the NEC Article 362. The trade sizes are 1/2, 3/4, 1, 11/4, 11/2, and 2. Flexible metal conduit, or FMC, is a racewave circular cross-section made of helically wound, formed metal. Flexible metal conduit is covered in the NEC Article 348. The trade sizes are 1/2, 3/4, 1, 11/4, 11/2, 2, 21/2, 3, 31/2, and 4. Liquid-tight flexible metal conduit, or LFMC, is a racewave circular cross-section having an outer liquid-tight, non-metallic, sunlight-resistant jacket over an inner flexible metal core with associated fittings. Liquid-tight flexible metal conduit is covered in the NEC Article 350. The trade sizes are 1/2, 3/4, 1, 11/4, 11/2, 2, 21/2, 3, 31/2, and 4. Armored cable, or AC, is a fabricated assembly of insulated conductors in a flexible metallic enclosure. Armored cable is covered in the NEC Article 320. Metal-clad cable, or MC, is a factory assembly of one or more insulated circuit conductors with or without optical fiber members enclosed in an armor of interlocking metal tape, or a smooth or corrugated metallic sheath. Metal-clad cable is covered in the NEC Article 330. Non-metallic sheathed cable, or NM, is a factory assembly of two or more insulated conductors having an outer sheath of moisture-resistant, flame-retardant, non-metallic material. Non-metallic sheathed cable is covered in the NEC Article 334. The type of wiring method being used, such as electrical metallic tubing, or electrical non-metallic tubing, or flexible metal conduit, or liquid-tight flexible metal conduit, or armored cable, or metal-clad cable, or non-metallic sheathed cable will affect the support requirements. Also, Section 300.11 says that wiring methods shall be supported so that the wiring will not be damaged when the ceiling is dropped or removed. And 300.11b says that cable trays shall not be used as a support system for wiring methods. It also says that raceways shall not be supported by ceiling grids. In addition, Section 300.11c says that suspended ceilings shall be permitted to support branch circuit wiring and associated equipment where installed in accordance with the ceiling system manufacturer's instructions. There is a lot of technical information that has to be reviewed for an electrical installation. The ampacity of conductors is covered in NEC Section 310.15. Ampacity is the current in amps that a conductor can carry continuously under the conditions of use without exceeding its temperature rating. Conductors must be sized large enough to carry the load current without overheating. There are many tables in the NEC that list the ampacity of conductors. For example, Table 310.15b 16 lists the ampacity of insulated conductors rated up to 2000 volts, 60 degrees Celsius to 90 degrees Celsius. Not more than 3 current-carrying conductors in a raceway are cable or earth directly buried, based on ambient temperature of 30 degrees Celsius. Correction factors are applied for ambient temperatures other than 30 degrees Celsius. The Derriting factors for the number of conductors in a raceway are in accordance with Section 310.15b 3a. Voltage drop is the decrease in voltage along a conductor due to the impedance of the conductor. Excessive voltage drop can cause equipment to malfunction. The NEC recommends that voltage drop on branch circuits not exceed 3% and the total voltage drop on feeders and branch circuits not exceed 5%. Voltage drop can be calculated using the following formula: voltage drop equals 2 times length times current times impedance divided by 1000. Conduit fill is the percentage of the cross-sectional area of a conduit that is occupied by conductors. The NEC limits the amount of conduit fill to prevent overheating of conductors. The maximum allowable conduit fill for 3 or more conductors is 40%. Conduit fill can be calculated using the tables in Chapter 9 of the NEC. Grounding is the connection of electrical equipment to the earth. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electrical shock. Grounding is required by the NEC for most electrical equipment. Bonding is the connection of electrical equipment to each other. Bonding ensures that all metal parts of electrical equipment are at the same voltage potential, which helps to prevent electrical shock. Bonding is required by the NEC for most electrical equipment. Overcurrent protection is the protection of electrical equipment from overcurrent. Overcurrent can be caused by short circuits or overloads. Overcurrent protection is provided by fuses and circuit breakers. The NEC requires that overcurrent protection be provided for all electrical circuits. Short circuit is an abnormal connection between 2 or more conductors. Short circuits can cause large amounts of current to flow, which can damage electrical equipment and cause fires. Ground fault is an abnormal connection between a conductor and ground. Ground faults can cause electrical shock and fires. Arc fault is an unintentional electrical arc. Arc faults can cause fires. The NEC requires that arc fault circuit interrupters, or RSIs, be installed in certain circuits to protect against arc faults. Surge protection is the protection of electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes or other events. Surge protection is provided by surge protective devices, or SPDs. The NEC recommends that surge protection be provided for all electrical equipment. In summary, addressing the city's concerns requires a comprehensive approach. It involves demonstrating that the use of Underwriters Laboratories listed clips, in conjunction with the ceiling grid system's load capacity, provides a safe and code-compliant method for supporting manufactured wiring. Open communication with the electrical inspector and providing thorough documentation are crucial steps in resolving the disagreement. The NEC permits the ceiling support system to support branch circuit wiring and associated equipment where installed in accordance with the ceiling system manufacturer's instructions. Even with the ceiling manufacturer not providing specific instructions, the use of UL-listed clips means they have been tested and meet Underwriters Laboratories safety standards.